Spiders. Tiny creatures that have mastered one of the most incredible engineering feats in nature, spinning webs. But how do they do it? How does a creature smaller than your hand create silk stronger than steel, flexible as rubber, and designed to catch prey with pinpoint precision? Today, Brain Tenacity reveals the astonishing science behind spider silk and the art of web weaving, a story of biology, physics, and evolution that will leave you in awe. Chapter 1. The Marvel of Spider Silk. Spider silk is one of nature's most extraordinary materials. It's stronger than steel, yet incredibly lightweight, flexible enough to stretch without breaking, yet sticky enough to trap flies mid-flight. Spiders produce this magic through silk glands in their abdomen, each gland specialized for different silk types. Dragline silk for the framework of the web, capture silk for sticky spirals that trap prey, tubuliform silk for egg sacs. A single spider can produce multiple types of silk, all controlled with amazing precision, a biological engineering marvel. Chapter 2. Anatomy behind the web. The secret lies in the spider's spinnerets, small finger-like appendages at the tip of its abdomen. Each spinneret has dozens of microscopic spigots, capable of releasing liquid silk proteins. When these proteins exit the spinnerets, they solidify instantly in the air, forming fine threads. But here's the mind-blowing part. Spiders don't just spin randomly. Their nervous system calculates angles, tension, and geometry, constructing webs that are not only functional but optimized for prey capture. Chapter 3. The web building process. Building a web is a step-by-step procedure. First, the spider releases a bridge line, letting it float on air currents to anchor to distant points. Then it creates a Y-shaped framework for structural support. Next comes the radial lines, like spokes of a wheel, providing strength. Finally, the spiral sticky silk is carefully added to capture prey. It's a design that balances strength, elasticity, and adhesive properties, all calculated instinctively. Chapter 4. The science behind the silk. Spider silk is a protein-based polymer made primarily of spidroin. Despite being liquid inside the spider, it transforms into a solid fiber stronger than steel of the same diameter. Its molecular structure allows both tensile strength and elasticity, creating a web capable of surviving storms, catching insects, and even supporting the spider's own weight. Chapter 5. Webs in nature. Not all spiders spin the same webs. Orb weavers build circular webs. Funnel weavers craft tubular webs. Cobweb spiders create tangled three-dimensional networks. Each web is adapted to the spider's environment and hunting strategy. Some even recycle silk, eating old threads to reuse the protein efficiently. Nature's efficiency meets engineering brilliance. Chapter 6. Lessons from spider silk. Humans are inspired by spider silk for bulletproof materials, surgical sutures, and even artificial fibers. Scientists study the chemistry, physics, and biology behind silk to engineer materials stronger, lighter, and more flexible than anything we've ever created. What's remarkable is that a tiny spider perfected this art without any human technology, evolution as the ultimate engineer. The next time you see a spider web glistening in the morning sun, remember, you're witnessing a masterpiece of nature. A delicate balance of strength, precision, and beauty, spun by a creature smaller than your hand. Spider silk isn't just survival, it's art, science, and engineering combined. Truly, nature is the ultimate innovator. If you found this incredible, hit like, subscribe, and turn on notifications for more amazing science discoveries with Brain Tenacity.